Hello everyone, welcome back to our YouTube channel. I'm Srikanth Reddy. Today we are back with another contest, which is LeetCode Weekly Contest 399. Let's begin with the first question, which is find the number of good pairs 1. Okay, so we'll just deep dive into the problem statement. You're given two integer arrays, nums1 and nums2, with the corresponding lengths n and f. Okay, and additionally, you're also given an integer k, a positive integer k. All you have to do is we have to return the total number of good pairs. A pair is called good. A pair I comma j is called good if nums1 of I is divisible by nums2 of j into k. Okay. So he says that you are given an integer k. All you have to do is just calculate the number of good pairs. A pair I comma j is good if nums of I is divisible by nums2 of j into k. Okay. So if you look at the example input for the first array, which is nums1, which are having the elements 1, 3, 4, and nums2 as well having 1, 3, 4, and k equal to 1. Of course, you can consider this as a pair, this as a pair, and again this as a pair. Again, we can also consider this as a pair and this as a pair. Okay, so these are the five good pairs. The same way you have to calculate the number of good pairs. That's a problem statement. So do you get any logic for this? First, we'll look into the constraints. Here we are given 1 less than or equal to n comma m less than or equal to 50. Okay, so the constraints are very less. So if you just implement a brute force solution, that would be fine. So what's a brute force logic? What's a brute force logic? As simple as that, what will you do? For this element 1, you'll check with 1, 3, 4. Again, when you're done with this element, you'll go to this 3, and again for this 3, you'll do the same simulation for 1, 3, 4. Once you're done with 3 as well, you'll go to 4 and you'll do the same simulation part for nums12. That's a brute force solution. In general, we are simply considering all n by m pairs from nums1 and nums2. That's it. That's it. So, just pause the screen. Try to code it up. Okay. Even though if you didn't get, then you can resume the video and you can see the solution. Okay. Let's code it up. First, we'll assume the number of good pairs initially are 0. Let's say answer equal to 0. Now, you just need to consider all n by m pairs from nums1 and nums2 respectively. For that, what will you do? Simply for I in range of length of nums1 and again for j in range of length of nums2. So whatever he required, we'll just copy it from here. If mod this. So overall, if nums1 of I mod nums2 of j into k is equal to 0, only then we can say that nums1 of I is divisible by nums2 of j into k, right? So then if it is equal to 0, then we'll add up this pair to the answer. and at the end we'll just return the answer. That's it. Okay, let's submit it. Okay, that's it for the solution, guys. We'll move on to the next question. So this is the second question, compressed string. So we are given a string word, we have to compress it using the following algorithm. Okay, begin with an empty string, compress. Okay, comp. While word is not empty. Okay, as long as this word is not empty, we should do some operations. So what is it? Remove the maximum length prefix of word made of single character C, repeating at most 9 times. Okay, then append the length of prefix followed by C to comma. Simple. Okay, I'll make it more clear with the example input. Okay, for this input, where all the characters in this word are distinct, are unique, in fact. So the frequency will also be one for every element, right? So you'll first remove A and you'll place 1A. This is the comp. This is the comp as of now. Let me write it over here. Okay. So if this is my empty comp, after when I'm at A, as there is no other A which is towards the left of A, it will remain 1A. Next, I'm done with A. Now I'll go to B. Again for B, 1B. Again for C, 1C. Again for D, 1D. Again for E, 1E. That's it. That's a output. Now, here comes the main thing that you have to understand. For this particular example, the answer is not 1A, 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 1A. It is 9A, 5A, 2B. Okay, it is because in the question he mentioned that we should remove a maximum length prefix of word made of single character. Okay, where the maximum length prefix of word here is character A, and at most 9 times repetition. Okay, for that reason, we'll just consider the characters 1, 2, 3, 4, 5, 6, 7, 8, 9. We have to consider only 9 characters at max, right? So we'll consider this, which becomes 9A. Next, we'll start the process from the first, or we'll start the simulation from the beginning again after this 8. So we'll again start from here 1A, 2A, 3A, 4A, 5A. The next character is not A, so we'll stop here. And we'll write 5A. Next, we're at B. The next character as well is B. And the word is done. So we'll just print 2B. So this is the output which we need. Okay. So how will you solve this question? Here in example 2, he mentioned that apply the operations 3 times, choosing this. That's what we have done, right? Okay. Now, how do you code it up? So by looking at the problem statement, the complete explanation part, what do you understand? Have you seen similar problem somewhere else? Yes, right? In our basic contest, we have a question compressed string. In that question as well, I'm not saying that it's the exact same question, a kind of similar question we can say. Okay, so what I would suggest you is first solve that problem first and then come back to this problem so that it would be more better for you to understand or to code it up this part. Okay. Next, coming to the constraints, one less than or equal to word dot length less than or equal to 2 into 10 power 5. Okay. So more or less, I reveal the logic part as well. What are things you have to take care while iterating through the word string. You should keep track of the number of occurrences of the current character. If it exceeds 9, start the process from the scratch. If it is not equal to 9, if it is less than 9, if it is less than 9, just get it done. Or if the next character is not equal, just print the current answer and go for the next character. That's it. Until you have to continue this process until the word becomes empty. So this is a pure implementation based question. Okay. Pause the screen. I want you to convert the logic that we just discussed into the code part. Once you're done with the code, if you got any issues or if you're not able to code it up, just resume the video and watch the solution. Okay. Okay, we'll code it up. First, we'll assume that our answer string is empty. We can consider either comp or answer. I'll go with answer. Okay, I've considered an empty answer string. Now I have to consider some index to just iterate through the word. Okay, some index equal to 0. Now, as long as my index reaches the end of the word, I'll keep on doing something. Okay, so while my index is less than length of word, I'll do something. Okay, so what am I going to do in this? First, I need the current character that I'm having at the index position. So I'll say current equal to some word of index. So for this element, I should know the frequency, right? I should know the frequency which I'm having. So let's say the frequency is initially 0. Now, while my index plus frequency, as long as it is less than length of word and additionally as long as my word of index plus frequency is equal to my current character, right? Isn't it? Or is this enough, or are we supposed to maintain any other condition? Are we supposed to maintain any other condition? Yes, of course. What's the condition? Repeating at most 9 times, not more than that, right? For that, we'll just write some condition and the frequency less than that. As long as we have this, what we're going to do? Frequency plus plus, which is in fact frequency plus equal to 1. Once we are done with the while loop, what do we do? Either the length of word has reached the end, or as long as word of what do you say? The word of index is equal to the current element, or as long as frequency of the current character less than that. Only on these three conditions will keep on moving inside the word. Okay, once we are done with this while, what do we do? We can add some resultant to our answer. So what do we add? answer plus equal to, you'll concatenate something to the existing answer, right? So what do you do? First, you need the frequency of it. So I can simply typecast it to string and then add it to answer. And also, I have to add the current character. So this is what I'm supposed to add. After this, what I have to do, what I have to do, I should just start from the next index, right? As in, if I'm done till the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 years, I have to start my process from the 10th year, not from the second year. For that, I have to update my index. Right, updating the index is the most important thing here. So index plus equal to how many times you'll just move your index. Just the frequency number of times. So I'll just say frequency. And then just return the answer. That's it. Okay, I'll just submit the code. Yeah, that's it with the solution, guys. We'll move on to the next question then. Cool. So this is the third question. Find the number of good pairs again. The problem statement, everything is same except the constraints. Here the constraints say that 1 less than or equal to n comma m less than or equal to 10 power 5. Okay, so what's the difference? We got a brute force solution where for n equal to m equal to 50, if we implement a n by n solution, n cross n solution, it will work. But here, if we implement an n cross n solution, it would be 10 power 5 into 10 power 5, which is 10 power 10, which will of course give us a TLA as expected. So what was our brute force logic previously? For this element 1, you are considering all the pairs 1, 3, 4. Again for this element 3, you are considering all the pairs 3, 1, 3, 3, 3, 4. Again for this, you're considering all the pairs which are 1, which are 2, sorry, 4, 1, 4, 3, 4, 4. So what exactly is taking time over here? For each element, you are reiterating through the same array again and again and again. So this is exactly where the time is being killed. So this is the exact origin for the scope of optimization. How do you optimize this? How do you optimize this part? Once you got an element, you should be somehow able to configure them in such a way that if you encounter the same element for the next element, you should be able to store it some way or the other. That thing we know. Okay, so I just want you people to figure out this part. Just think about it. Okay, so we'll again go to the second one. For the second one, our ultimate task is to achieve this nums1 of I divisible by nums2 of j into k. Into k is something that is giving some extra information. Okay, if I consider nums2 of j into k, I can simply consider 2 into 3, 2 into k, which is 2 into 3, 6. Next, 4 into 3, 12. So these are my nums2 elements, more or less. Now, for all the num1 elements, I have to just simulate this condition. Okay, so how will you do that in an optimal way? How will you do that in an optimal way? Here, one more thing you need to understand here is, if you consider the element 12, it's not like all the elements of num2 will definitely be divisible by 12. I'll just rephrase this. 12 will be divisible by all its divisors. What are all the divisors of 12? What are all the divisors? 1, 2, 3, 4, 6, and 12. That's it, right? So these are all the 6 possible divisors. Now, it is clear that for 12, any element other than these 6 numbers will definitely won't be a divisor for sure. So, what all things you have to search for in our nums2? You should only check whether 1 is present as a divisor in nums2 or not. Next, 2 is present or not. 3 is present or not. 4 is present or not. 6, 12. If you are able to do that, our task is simply done. So, for this example, 6 is a divisor. 12 mod 6 is 0, yes. Again, 12 mod 12, 0, yes. So, your output is 2. If in case you might have more 6, 6, 6, 6, 6. What would be the answer then? This 12 can pair up with this 6, this 12 can pair up with this 6, and of course 12, 6, all the distinct indices of I comma j, we can form all the possible pairs. Okay, I want you to figure out the implementation way for this. I told you the logic, right? I want you to just convert this logic to a code. That's it. Pause the screen, guys. Try to convert this logic into code. Check whether any data structure helps you in achieving this in an optimal way. Okay, you're good to go. Okay, let's discuss the detailed logic part. We will consider both our nums1 and nums2. Okay, nums1 equal to 1, 2, 4, 12 and 2, 4. Okay, 1, 2, 4, 12. And nums2, 4, right? Yeah, 2, 4. 2, 4, and our value of k is 3. As discussed, we'll consider every element of nums2 being multiplied with k. With that, we'll get 6 and 12. Okay. Now, what you have to do for this element 1, okay, we'll start with element 1. For this element 12, we know that the divisors are 1, 12, next 2, 6, next 3, 4. That's it. These are the 6 distinct elements which are the divisors of 12. Okay, so what exactly I'm going to search in my nums2? I'll check for the existence of a divisor in nums2. Okay, now I'll check whether 1 is present in my nums2 or not. So this is the updated nums2, right? I'll just consider it this way. Updated nums2. Now I'll check whether 1 is present in my nums2 or not. If 1 is present, I can consider 12 as a pair. Okay. Saying that nums1 of I is divisible by nums2 of j into k. Okay. This is the case. Next, I'll search for 12. Yes, 12 is present. Then I can consider it as a good pair. Next, 2. 2 is not present as a element in our updated nums2. So we'll skip this. 6 is present. So I'll consider this to a answer as a good pair. In fact, 3 is not present, 4 is not present. So what if we have the element something like 10 power 3, 10 power 3, 10 power 3, or 10 square, 10 power 4, etc. Irrespective of the length of nums2, we just need to search only for the divisors of 12. That's it. This is the core logic behind it. I'm repeating it again. Irrespective of length of updated nums2, we should only search for the divisors of nums1 in nums2. That's it. So if we linearly search for the divisor, we'll anyhow take m time. Overall, the complexity will turn out to be n into m, which is same as the previous solution. So what's taking time here? Searching is taking time. So how do you implement searching in an optimal way? Using the most famous data structure, hash set. Hash set. Okay. Now we'll just add 6, 12 to a hash set, and of course 10 power 3, 10 power 3, 10 power 2, 10 power 4, all this. Now you can search for 6, you can search for 12 in O of 1 time. But if I implement the exact same thing, will it be valid? Will it be valid? No, right? No, right? What's the reason? In our actual updated nums2, there might be duplicates as well. For example, 10 power 3, 10 power 2, and then 6, 6, 6, 6, 6. If you add it to a hash set, you will lose all the sixes. So instead, what you have to maintain? Instead of hash set, you need to maintain a hash map. So what will you store in the hash map? The element and corresponding frequency. Okay, for this element 6, what will you store? 1, 2, 3, 4, 5, 6. As the frequency of the element 6 is 6, so you will store 6, 6. 12, 1, 10 power 3, 1, 10 power 2, 1, and so on. This is the way how you use a hash map data structure. So do you understand how we are breaking down the problem? First, we are figuring out what exactly is taking time in our brute force solution. And while optimizing the solution, we came to know that we should somehow search the divisors of nums2, divisors of nums1 of I in an optimal way in nums2. For that reason, we have added it to a hash set. But this approach is correct, but it will of course give us a wrong answer. For that, you can refer this test case where the array have duplicates. The array may also have duplicates. Right? For that case, you'll miss all these pairs if you use a hash set. You'll miss all these pairs You'll consider a single 6. You'll encounter a single 6. But in fact, you can consider 12, 6, next 12 and this 6, 12 and this 6, and this 12 came from nums1, okay. We can consider this 6, this 6, this. All these are the good pairs. So with this, we should somehow do it with this. Now, what do you do? What do you do? For 12, you have the divisors which are 1, 12, 2, 6, 3, 4. If you have this 1, you are now not having it. 12, it is present, so you'll assume answer as 0 initially, and after this, your answer plus equal to HM of 12, which is 1. So you can say that there exists one pair which is 12, 12. Next, when you encounter 6, 6 is present. So you'll add it something like this, HM of 6, which is a divisor. Next, 2 not there, this 2 not there, 6, we're done with that. 3 not there in the hash map, 4 not there in the hash map. So this is what we are supposed to do in the code part. So how will you write a code for this? How will you write a code for this? I'll write it over here. First, on step 1. Step 1 is to add the elements of, I'm writing the steps here. Step 1, add elements of nums2 to a hash map. So how will I do that? Simply for int element in nums2, I'll directly update the hash map. So if element is in hash map, what will I do? Update the frequency of it. Or we can directly write update HM of element with plus plus. Else, you'll just place that element. You'll just place that key to a map. That's it. Or instead, we can place element into K. That would be even better, right? That's even better. So what we're going to do, let us consider some x which is equal to element into K. So what will you write? If my x is in hash map, what will I do? HM of x plus plus. Else, what will I do? Or to write the exact syntax, hm dot put x comma hm dot get x plus 1. Else, you'll simply put x comma 1. So we are done with the step 1 where we are adding the elements of nums2 to hm with the where every element of nums2 being multiplied by k. Now, step 2. We'll just iterate through the divisors of every nums1 element. Iterate through every divisor of nums1 of I of nums1 of I and update the answer accordingly. So what will you do here? What will I do? First, you'll just consider some element in num1. I'm writing a for each loop. Okay. Now I'm at some particular element. What will I do? I just have to consider all the divisors of it. How will I get that? For int j equal to 1. Next, as long as my j into j is less than or equal to element, what will I do? If my element mod j is equal to 0, first I will have to check this. If yes, I'll check whether if my j is present in the map or not. If yes, I'll directly add this to write the exact syntax again. hm dot get j. If this is the case, I will do this. Or we have one other case where j into j can be it can be not equal to element, but still there might be a case where it exists. The exact case is the j not equal to element by j. And again, if my element by j as well, if my divisor as well is present in map, then what will I do? Answer plus equal to hm of element by j. That's it. That's it. And then you'll just return the answer. So we did nothing new. As what we discussed in our logic, we converted the same thing in the code perspective and we wrote the code. Okay. Sorry, this is not step 1, this is step 2, right? Okay, that's it. Now start writing the code and get it done. Now first I'll consider some dictionary. As I'm using Python, I'll go with dictionary. If you're using Java, go with hash map. Okay, first I'll consider a default dictionary, and now I'll just store the elements of nums2 to a hash map. For elements in nums2, I'll just add element plus equal to 1. Okay, as they're considering element into k, we'll go with element into k. Okay, now I'll initialize answer with 0. We're done with step 1. We just started step 2. Okay, inside this, inside this, what do we do? We'll just have to iterate through nums1. Okay, we're in a particular element. What do we do? We just need to iterate through the divisors of this element. Okay, for that, for j in range 1 to square root of it. So this square root function, I hope you people are already aware of it, right? If you just iterate till the square root of a number, you'll encounter all the divisors of a number. Okay, this is a standard standard algorithm. Okay, if you're still unclear about it, just take some random value of n and check. If you iterate till root n, you'll encounter all the distinct divisors of n. Okay, so I'm just iterating till root n. So element till 0.5, which is 1 bit, of course. Plus 1. Okay, I'm iterating from 1 to root of that element. So with this, I'll just do if my element mod j, if my element is divisible by j, then If my j is present in hash map, what will I do? I'll just update my answer with hm of j, not else. If and also if my j is not equal to element by j, and if my element by j is in hm, in this case I can update my answer again with element by j. Okay, here I will directly return the answer. We'll run the code. Okay, it gave us some error. What is it? Uh, yeah, we didn't declare the data type for this. Yeah, we'll run again. Yeah, it's done. Submit and yeah, that's it, guys. That's it for this question. So that's it for the video, guys. If you found the explanations helpful and enjoyed the problems, please consider subscribing and share the questions and solutions to your friends.